Alright, now serious question. Three identical cylinders, each of mass m and radius r, are in contact and kept on a rough horizontal surface. So here we can see three identical cylinders. They are in contact, each having same mass. The friction coefficient between the cylinders is 0. Okay, but the ground is rough. Coefficient of friction between any cylinder and surfaces is mu. A force F equal to mu mgt acts on the first cylinder. Mark the correct statements. So let's see the statements. The cylinders will start pure rolling and keep on pure rolling. So we have to check whether the cylinders will keep on pure rolling or not, and if they will start slipping, at what time will they start slipping. Okay, so first of all, let's draw the FBD. So I got the three cylinders. So this is my first cylinder, and this is second cylinder, and this is the third cylinder. Okay, now since the cylinders are uniform, I can write the torque equation about their instantaneous axis of rotation. So the instantaneous axis of rotation will be near the bottom. Now let's draw the FBD. So here we have the external force F acting over here. Then we have N1 action reaction, then N2 action reaction. We also have friction. Okay, so friction will be same in all the three cases. Why is that? Let me tell you. Since the cylinders are always in contact, they have same acceleration. They have same acceleration means they have got same angular acceleration also. Okay, so about center of mass, since the angular acceleration is same for all three, friction should also be same because they want the same torque about center of mass. So anyways, so that's it. So they all have angular acceleration alpha, correct? So about IAOR, about instantaneous axis of rotation. For the third cylinder, I can write down N2 times R will be, let me take some space, N2 times R will be, this is a cylinder. So about center of mass, moment of inertia is mr square by 2. About the periphery, so moment of inertia is 3 by 2 mr square. So 3 by 2 mr square alpha. I should write this capital R. Okay. So this is the equation for this first cylinder, or I got N2R. So N2R is this value. Now for the second cylinder, N1R minus N2R. For the second cylinder, N1R minus N2R is equal to 3 by 2 mr square alpha. But since N2R itself is 3 by 2 mr square alpha, so N1R will be 3 mr square alpha. Okay. Now coming to this object, first cylinder, so F minus N1. So Fr minus N1R will be again same things 3 by 2 mr square alpha. So now Fr will be what? N1R is 3 mr square alpha, so 3 plus 3 by 2. So 3 plus 3 by 2 will be 9 by 2 mr square alpha. Okay, so I get F is equals to 9 by 2 mr alpha. So I found alpha over here. Okay, mr alpha will be 2f by 9 equal to mr alpha. Okay, again going back to the first equation, N2R. So N2R is 3 by 2 mr square alpha, or N2 will be 3 by 2 mr alpha. N2 will be 3 by 2 mr alpha, so that is 3 by 2 into 2 by 9 f. So N2 will be f by 3. Okay, so now let's go back to this cylinder. So the net force is how much? N2 minus F, that is equal to MA. For the third cylinder we have N2 minus friction is equal to MA, that is mr alpha. Acceleration of center of mass is r alpha, right? So since N2 is F by 3, okay, so F by 3 minus friction is equal to mr alpha is how much? 2F by 9. 2F by 9. So friction will be F by 3 minus 2F by 9. So that is F by 9. Okay, this is your friction. But the normal force between the cylinder and the ground is how much? Equal to mg. So friction should be less than equal to mu mg. Okay, that means F by 9 should be less than equal to mu mg for static friction. Okay, for static friction. Okay, so F is what? F is given in the question to be mu mgt. So mu mgt by 9 should be less than equal to mu mg, or t should be less than equal to 9 seconds for static friction. That means up to 9 seconds there will be pure rolling. Beyond 9 seconds the cylinders will start slipping. Okay, so option B is obviously right and option A will be obviously wrong. Now we need to see option C. Velocity of center of mass of each sphere will keep on increasing. Is that true? So see, uh, it's simple logic. Friction is always there. Okay, or you could say that during static friction moment alpha is always there, right? So alpha is there means omega keeps on increasing, so velocity keeps on increasing. But even after the friction becomes kinetic, friction is constant. But F, N1 and N2, they are all increasing continuously with time. F is increasing continuously with time. So that means the cylinders will keep on accelerating and their velocities will keep on increasing. So obviously this is also correct. Okay. After a certain value of F, angular velocity of each sphere will become constant. No, that is false. Okay. Why is it false? Let's understand. Even when the friction becomes kinetic, friction is still acting. So about center of mass, there is always a torque due to the kinetic friction. Since there is a torque, there will be angular acceleration always. If there is angular acceleration, means the omega will keep on increasing. So this is wrong option.